In this video we will discuss about kinetics of a particle. So first method is D'Alembert method, where simple Newton's law is used. Summation of F is equal to m into a. So here if mass is there, it is moving with a acceleration a due to force P, and there is some resistive force like friction force or air resistance in opposite direction. So we can simply write the forces in the direction of acceleration will be positive. So here P minus F, summation of force, will be equal to m into a. M is the mass of the object and a is the acceleration of the object. So this is how we can use this equation, and this is called as D'Alembert method. The second is work energy method, where whatever the work we do on the body, work done on the body will be equal to change in kinetic energy of that particular body. So here if we see there is a this rectangular body with initial velocity u, and there is some forces acting opposite direction to that of the displacement. So this is S is the displacement, and there is initial velocity, and after that it comes to stop, where final velocity is equal to 0 after traveling distance s, and this is due to the force F which is acting. So now if you want to write work energy method, this force is doing some work on this body, that's why it comes to stop. So here work done on the body is a summation of F dot ds, force into displacement, will be equal to change in kinetic energy, which will be final kinetic energy half mv square minus half mu square, which is initial kinetic energy. So change in kinetic energy is this, and work done on the body summation of F dot s, so that will be equal by work energy method. So here if you want to write, there is no force in the displacement direction, displacement is in this direction, so 0 minus F means force is opposite to displacement, that's why minus F dot, this S is displacement, total displacement. So this is the work done by the force F, because it's a negative, that's why it comes to stop. Now that will be equal to change in kinetic energy. Change in kinetic energy is final kinetic energy, which is 0 because V is 0, and initial kinetic energy is half mu square. So if we equate this, then we get this equation. So this is how we use this equation and find the variables. And one more example here, if we see that if mass is having velocity u and there is no force acting, it will continue to have that velocity until it reaches here at this plate, which is connected to a spring, and this spring is connected to the wall. Now if you see, until this point where it touches this plate, there is no force is acting, that's why the velocity will remain constant. After coming here, there will be force in the opposite direction because the spring will get contract. Now the spring will do work on the body, and body will come to stop after some point. So let's say at this particular point spring contracts and block comes to this particular position where its velocity becomes 0, and it travels distance s. So here if we see spring work, which is equal to half k into x square, or we have to do it by integration. This result comes from the integration 0 to s f ds ds dash means at some particular s dash distance, like a dx distance I have taken ds dash distance, and force is minus k into s dash. So here s dash is a variable from this particular point, s dash is some particular variable. Now if we integrate, we get half k x square, which is a total spring work until it comes to stops. So here spring work is this, we got it by integration. Here force is not constant, spring is exerting force on the body with which is proportional to the displacement of the spring, which is s dash. Here the F equal to minus k s dash. So here if we integrate it from 0 displacement to s displacement, we get half k x square s square. So half k s square is the work, and which is in opposite direction to the displacement, that's why minus spring work equal to change in kinetic energy. Change in kinetic energy is final velocity 0, so 0 minus initial kinetic energy, which is half mu square. So if we equate this, we get this equation. And then I have discussed negative means spring force and displacement are opposite. Similarly here friction force is opposite, that's why we have to take negative. The negative as of displacement. So displacement and force are in same direction, we have to take it positive, force as positive, otherwise negative. And the third method is impulse momentum method, where impulse is equal to change in momentum of a body. So impulse is summation of f dot t. T is the time of collision or impact. So if we hit a ball with a bat, then there is particular momentary force transfer, and it is for particular time t. So impulse is for a short duration t, forces are acting on the body. So summation of f dot t will be equal to change in momentum of body, which is mv, final momentum, minus initial momentum, mu. So m common, v minus u, and this equation is used if f is constant. Otherwise we have to integration f dot dt equal to m v minus u if f is a function of time. So here if we place function of time, and then we can find the initial and final velocity. V is the final velocity and u is the initial velocity, and m is the mass of the object. So this is impulse momentum method. Please do solve the numericals on this from standard textbooks, or gate pyqs or some other exam pyqs. It's a basic equations are used, fundamental concepts are used in such questions, and you can easily score 2 to 3 marks, because it is coming alternate year or every year. By work energy method, you can use either of the method, it all works. But if in question displacement is given, work energy method will be faster. If the time is given, then impulse momentum method will be faster. Likewise, if acceleration is there, then the de-impulse method will be much faster. So you have to pick whichever method, but you will get result from all the three equations. So thank you for watching this video, and see you in the next video.